Okay, students, good evening. Okay. Uh, just now we completed one lesson, isn't it? P block elements we completed. Now we are going to start the new lessons. Very simple lesson. We studied in lower classes. Okay, 10th standard is there. Okay, how to extract metal from the ore. That process called, we can say, metallurgy. Okay. So if you want to extract metal from the ore means, so immediately we cannot get. See, it has so many processes are there. Understood? So first of all, you should know what are the major process involved means. These are the major process involved. So after, first of all, we are getting minerals from the earth crust. Okay. So from the mineral only, some minerals having more amount of, large amount of metal is there. Some minerals having not large amount of metal is there. So anyone having more amount of metal is there, that's called, we can say, ore. Okay, so if you have less amount of metal is there, no use at all. Even though if you extract, we are getting only less amount of metal, so no use at all. Okay, if you want to extract metal, it will take, the cost of extracting is more, but yield is very, very less means no use at all. So anything having more amount of metal is called what? Ore. Understood? So from the ore only we are going to extract metal. Okay. So before that you studied ore in the form of sometimes the metal in combined state, sometimes metal in free state. Whenever metal in free state is called what? Native ore or native state. No. So the metal in the form of two state, combined state as well as native state. Native state means to the metal no other elements are there, only the sand particles will be there. That is called what? So we can say ore classified into what? To native ore or combined ore. Combined. Okay. Native means only to the metal only the sand particles will be there. Suppose gold, platinum, these are all native ore. Combined means all this HGS, P.B.S, zinc blending. Okay, everything is called if you want to extract zinc means it is in the form of zinc sulfide. If you want to extract lead means it is in the form of lead sulfide. If you want to extract mercury means it is in the form of HGS. So it's called combined state, native state. Okay, right. This is all you know. And then we have types of ore, isn't it? Types of ore means sometimes ore in the form sulfide ore. This is sulfide ore, no? Sulfide ore. Oxide ore means, okay, we have classified into many kinds of ore, no? Sulfide ore. Sulfide ore means these are all sulfide ore. HGS, P.B.S, ZNS. Cut or not? Oxide ore means, best example what? Al2O3, Fe2O3, hematite. Bauxite, hematite. Okay, understood? Then sulfate ore. Sulfate ore means what? CaSO4, .2H, gypsum, milk of magnesia, magnesium sulfate. Understood? The ore in the form of sulfate, SO4, no, sulfide, oxide, okay, or carbonate ore. Carbonate ore means what? Carbonate ore, calcium carbonate, zinc carbonate, calamine. This is called, this is called calamine. Okay, right. Limestone. This is calcium carbonate. CaO is called quicklime. Okay, so like this, so many things are halide ore. Halide ore means what? Sodium chloride, magnesium chloride, halide ore. Then silicate ore. So many things are there. Okay, this is all Okay, so. Understood? So this is called ore in the form of two different kinds. Then ore in the form ore nothing but in which here we have some kinds. It will be in the form of sulfur is present, sulfide ore. Oxide is present means oxide ore. Sulfate is present means sulfate ore. Carbonate ore. It goes on. Okay, understood? Are you following? Okay. Next one. Here now directly I am going to say important things about how to extract the metal from the ore. So first one, after get the ore from the earth crust, first up, okay, immediately we cannot process. First we should what? Concentration of ore means what? Washing. ore is washed by different method. Okay, that's called nothing but concentration of ore, nothing but what? How to washing the ore. Okay, so after removing some unwanted substance from the ore, okay, then only we can process. What process? How to remove metal from the ore. Okay, after remove the metal from the ore, it's not pure. After extract, after separate, extract means just separate. We just separate the metal from the ore. That's all. But it's not pure, no. So we have to what? Refine. Refine means purify. Then only at last only we are getting what? The 100% or 99% pure metal we are getting. Okay. So these are the main important process under metallurgy. Understood? First of all, we are going to do the concentration of the ore. Okay. So concentration of ore, under this we have 4 types. We have 4 types. One is, gravity separation process. Gravity separation process. Otherwise it's called what? Hydraulic process. Hydraulic process. Another one is, froth flotation process. Froth flotation process. Another one is, magnetic separation process. Magnetic separation process. Another one is, leaching process. Understood? Leaching process. Understood? You following? These are all the method to wash the ore. Okay. So here, if we have different kind of ore, we are following different method to wash the ore. Okay. Understood? After completing 12th standard, someone goes to arts college, someone goes to professional college. You are all going to. You have one aim. Is it to become a doctor? No. Then only you are coming here. Okay. So after 12th standard, so different students having different aim to study the higher study to complete your higher courses. No. Then only the different students giving studying different courses in their higher studies. Then only, ore is same, but it has a different kind of we are following the all are the common meaning is called washing the ore. That's all. Okay. So how to wash the ore means a different kind of ore or washed by different method. That's all. Okay. Suppose if you have heavy ore means mostly iron ore. Iron ore means we are washed by what? Current of water. Simply remember. Okay. Current of water. Current of water means when you pass high current of water, or if you pass water with high force, if any unwanted substances are easily removed from its surface. So a heavy ore, like okay, like what? Hematite. Understood? Iron ore mostly can be washed by this method. So just using what? Current of water. Current of water is given. Current of water nothing but, what's the meaning for current of water? We are passing water with high force. Okay. So that's called current of water. Okay. Understood? Right. When you pass water with high force, any unwanted substance, any sandy substance, any rocky substance are easily removed from its surface. Then now what? Now the ore will be now ore will be what? Washed. Ore will be purified. Okay. Gravity separation. Gravity separation means there's a difference in gravity between here. What's the principle behind means? Difference in gravity between what? The ore and the minerals, sandy substance. Okay, understood? What is the, that? What is mineral? It consists of what? Ore plus, what? Gangue, cut up. Gangue, okay? Or it's called, you can say matrix, or it's called matrix. Okay, this gangue nothing but what? Sand or rock, or some rock will be there, rocky substance, or some we can say it's called dust. Okay, or this is called gangue substance. Okay, so our aim is to get only ore. So if you pass with high current of water, this will be easily removed. Now we have only ore. We have ore. After that we can able to process. Understood? Okay. You can say what's the principle behind means. What's the principle behind? You just write difference in gravity between ore and gangue. Just write difference in gravity between ore and gangue. Are you following? Difference in gravity between ore and gangue. Gravity. Why it's not going? Why this ore is not going? It is heavy ore. Only dust particles are only lighter. Lighter particles are easily washed away by water. Understood? Right. Froth flotation. Froth flotation only. What kind of ore can be used by this method? Very important. Sulfide ore. Understood? Okay. Then here we are using three things you just keep in mind. One is called collector. Okay. What's the principle behind means? Just write here. What's the principle behind means? Ore and gangue. Just remember. Okay. Ore is wetted by oil. Gangue is wetted by what? Water. That's the principle behind. Ore particles are adsorbed on oily substance. Gangue particles are adsorbed on watery substance. That's the principle behind. Okay. So here we have three things. Just remember: collector, froth stabilizer. Okay. Then I think depressant. This is very important. Depressant. Okay. Collector means it makes the ore, it makes the ore, or it is the non-wettability. So it makes the ore in non-wet condition. Suppose here, it makes the ore dry. Simply we can say. Okay. So it gives, or simply we can say non-wettability property. This one is given in your textbook. Non-wettability property is given by. That's the purpose for adding collector. Okay. It's not, it helps the ore to become non-wettability. Okay. Or it helps the ore to become dry. Okay. That property is given by what? Collector. Understood? Froth stabilizer means it makes the, in this method at last we are getting froth. Froth will be formed. To stabilize the froth, or it maintains the froth as it is means, then only we are using one substance called froth stabilizer. Okay. Then one example is given. Tell me, you already studied, no? One examples. What is the collected examples? Xanthate, pine oil, correct or not? Okay, xanthate and pine oil. Here froth stabilization means anisole, correct or not? Anisole, cresol, this all is given. Then depressant example is, what is depressant means? We have sometimes it allows one of the ore to become froth. Suppose if you have two ores are there, one is 85% one ore. We have two different kinds of ore is present means. Are you following? It allows one sulfide ore become froth. Okay, we have two kinds of ore. It allows one become froth, one make them to settle down at the bottom. Okay, that's the purpose for adding depressant. Depressant means best example, sodium cyanide and sodium carbonate is also given. Especially sodium cyanide is the best example. Okay. For example here, PBS and zinc sulfide ore. Two kinds of ore is there. If you add sodium cyanide, the sodium no, it allows PBS to form froth. It combines with this one to make them to settle down. See, NaCN combines with this one to form a salt. So it will settle down. Froth means what? It's weightless, no. Froth means it is weightless. Then only it will come up. Okay. So suppose these two are reacted together, what happened? These two are reacted together means the density is more, no, it will come down. Okay. So the substance allows any one of the ore to become froth, and other make them to settle down. That's called what? Depressant agent. Depressant we can say. Okay. So these are the things. So you take sulfide ore, you add some oil, you add some these reagents, then you pass some compressed air. At last you will be getting froth will be formed. To the froth, the ore will be attached. Okay. Any gangue particles are settled down at the bottom. This is a way to separate the ore from the minerals. Then only it's called what? What process? Froth flotation process. Understood? Okay. Understood. So these are the conditions very important. Understood? Just go through. What kind of ore can be washed by this method? Sulfide ore only. Okay. Right. Next one, magnetic separation. This is simple one. Suppose the ore having any magnetic substance, magnetic roller is there, no? You saw the diagram. Okay. If you pass the magnetic substance along the magnetic roller, understood? When it comes to one end, if you have magnetic substance means it always attached to the magnetic roller. If non-magnetic substance means at one end it will be separated. So magnetic substance and non-magnetic substance are separated at one end. That's why magnetic separation method. Mostly, tin ore can be separated by this method. Tin ore means we have tin stone plus iron substance are present. Okay. Are you following? Simply you can say magnetic substance and non-magnetic substance are separated by this method. Okay, right. Then leaching. Leaching nothing but what's the principle behind? Difference in solubility. Difference in solubility. Solubility. Okay. Difference in solubility between what? Ore and gangue. Correct or not? Okay. We are adding some solvent. Okay. Ore can be dissolved, but gangue will not dissolve. Okay. One is dissolved, one is not dissolved means we can easily separate now. If you add some solvent. Together is there, everything is there. Our aim is to remove what? Gangue. We don't want this. If you process along with this, very tough to process. First of all, we should remove, we don't want this. That's our aim. Yeah. If you add any solvent, the solvent dissolve or the ore particles are dissolved in solvent. This will not dissolve. Okay. That's it. The process is called what? Leaching process. Understood? Leaching. Understood? The following mostly see there, best one is that you take it's a native ore or combined state? Native ore. If you take gold, only gold is there. Along with gold, no other elements are there. Only some gangue particles are there. So you take this one, then add H2O and dissolve in potassium. This ore is dissolved in all this to form one complex substance. The complex substance is called KAUCN twice, correct or not? KAUCN twice. Okay, plus KOH will be obtained. Okay, then again take the left hand side. KAUCN twice. Understood? Our aim is to get only gold. Zinc is added. What we get means we are getting gold plus K2 ZnCN4. Okay, see what's the difference between this and this? This and this. This is also gold, this is also gold. What is the difference between this and this? Separated. Here this gold having some sandy particle. Understood? The sandy particle will not react with this one, no. Sandy particle will not react with this one. Only gold only can react. then only that here everything together, gold with some sandy particle. But this is not reaction going on, at last we are getting only gold. Understood? Anyway, sandy particles are separated. Sandy particle will not form a compound. It's present as it is. Understood? Okay, right. So, ore is dissolved in the solvent to form a complex. From the complex only we are getting what? The gold. So here zinc acts as a reducing agent, very important. 1 mark they will ask, what is the role of zinc? It's a reducing agent. Okay. This process is called what? Cementation, no? One process I studied. Metal, but in CBC board is not there. That book is not there. But matriculation book is there. Cementation. Getting metal from its complex is called cementation. Okay, right. Understood? Are you following? So difference in gravity. Difference in, one can form froth, one cannot form froth. Difference in magnetic properties. Difference in solubility. So these are the way to, different ores having different character. Okay. So based on ore, we are doing different operation to remove the unwanted substance from the ore. Understood? So first of all, we should do only concentration of the ore. Understood? These are all important. Just go through all this. Okay. Okay. Next one. Finished? Just washing the ore, that's all. First we are taking, then washing the ore to remove the unwanted substance like gangue substance we are removing. Okay. That's called concentration of the ore. Okay. Next one. Next one is what? Extraction of metal from the ore, the second process. Extraction of metal from the ore. Okay. Listen. Say what are the process means? Second process nothing but extraction process, no? Extraction of metal from the ore. Okay. So first one, we studied already, roasting process, isn't it? Roasting, what is roasting? What is roasting? What is calcination? Roasting means heating the ore in presence of oxygen. Correct? Understood? Heating the ore in presence of oxygen. Here just heating the ore only. Okay. It becomes what? It becomes metallic oxide, no? Metallic oxide. Understood? Here also it becomes what? Metallic oxide. Just heating, not oxygen. Okay. Example. Only what? Overall commander here. Roasting means what? Sulfide ore we can say. Understood? Sulfide ore. Sulfide means I am taking zinc sulfide. It's roasted to become what? Zinc oxide. I told you, Understood? Plus SO2. 2, 3, 2, 2. If you put it balance. Here, what ore? Mostly carbonate ore or hydrated ore or commander in this category. Hydrated ore. Okay. Carbonate ore means example. Give an example. Carbonate ore. Carbonate ore, calcium carbonate, zinc carbonate. We can say like that, no? Calcium carbonate, zinc carbonate, magnesium carbonate. Okay. Any carbonate is heated, need not apply any just heated, need not apply any oxygen, isn't it? Correct or not? You are heating the ore in presence of oxygen, you are heating the ore in absence of oxygen. What do you get? Oxygen, the same oxide. Ca, Ca, oh no, plus what? CO2, correct or not? Okay, right, anything we can take. Zinc carbonate means what? ZnO plus CO2, correct? Understood? Right. Then, we converted, no, ore into metallic oxide, no. Then metallic oxide into metal, no. Metallic oxide into metal means then only we need what? Reduction process. Are you following? So many processes is there here also. What is reduction? Convert metallic oxide into what? Metal. Convert metallic oxide into metal by using what? What? Using reducing agent. It may be what? CO or C or any metal. Any highly reactive metal. Understood? If you put that reagent that converts metallic oxide into metal. Understood? Suppose for example, zinc oxide is obtained. Isn't it? If you put based on the metallic oxide, no. Okay. But if you put C means what happened? Zinc plus metallic oxide, no, into metal. So what? Plus, correct or not? Okay. Sometimes we can use metallic, sometimes CO also, carbon monoxide. These are all reducing agent. This reduces this into that. Metallic oxide into metal. Okay, this is all reducing agent. Okay. Already CO means it becomes what? Already seen a CO. It reduces this one. It reduces this one means this is going to oxidize meaning. Understood? CO becomes what? CO2 plus what? Fe only. After the balance equation. Okay. And it reduces metallic oxide into metal. So this is called what? Reducing agent. Understood? This is all reduction process. Okay. Understood? Sometimes we can say it's called smelting. Sometimes heating also we should do. Heating, reducing agent, all is necessary to convert any metallic oxide to metal is called what? We can say smelting. Okay, right. Here, based upon only we have some one diagram is given, Ellingham diagram. Okay, just we go through this one. Ellingham diagram means what? Here what? Here delta G naught we should take temperature. Okay, so when you delta G naught versus temperature from the graph only we can decide which kind of reducing agent for converting metal into metallic oxide. This will tell us about that's a role of this one. Okay, what's the important role of this one means choose the reducing agent to convert what? To convert metallic oxide into what? Metal. That's the purpose for introducing Ellingham diagram. In Ellingham diagram, how they are taking the graph means delta G naught versus temperature. Okay. You just go through this only. Mostly they will avoid that one. Okay, anyhow, just go through this one. But it will not tell about the stability of the, stability of the complex, okay, thermal stability, kinetic stability, this and all, it cannot able to explain, okay. It will choose which kind of reducing agent is suitable for to convert this into that, okay. Some reducing agent at low temperature, some reducing agent at high temperature we can use, okay. Okay. So we have so many reducing agent, no, okay, like that. Suppose here, for example, Fe2O3, sometimes aluminum is highly reactive metal can reduces low reactive metal, okay. Suppose here I want to get iron oxide into iron, no, that's the purpose, okay. I want to get metallic oxide into metal, I want. So if you use highly reactive, it is highly reactive than this one, okay. If you put on highly reactive metal, so it can be reduced, okay. So what happened? What's the product? It will be Fe, no, don't worry about the balance equation, just it takes oxygen, so it becomes what? Al2O3, okay. So then I put here, we can use C or we can use CO or we can use any highly reactive metal, understood? These all are used full to convert metallic oxide into metal, okay. So then only this elegant diagram is telling about which kind of reducing agent you can use to convert metallic oxide into metal, okay. That's the purpose for this one, okay. Okay. Then so many conditions are there here also, when you select the reducing agent, the reaction must be what? Delta G must be negative value. Then only reaction is spontaneously going on. These are all you should consider, okay. Right. Then the following: roasting, calcination, reduction, okay. Right. Then suppose one example I will give, extraction of copper from copper pyrites. Copper pyrites means what? CuFeS2. So it's a sulfate or no? Roast. If you do roasting, what happens? Just listen. CuTs plus FeS2 plus O2. Second step. This will be oxidized. This will be evaporated. No, don't worry. Now we have only this one and this one. It's a copper. Our aim is to get copper. No, we don't want this one. So how to remove this one means what? Or we can say FeS only. Sure. FeS. Any sulfide, if you see, means immediately we cannot immediately we should do roasting. Understood? Are you following? Any sulfide, if you see, means roasting. What happened? It becomes Fe2O3 plus SO2, not Fe2O3, FeO. Okay. Then whenever if you see FeO, how we can separate means by using roasting only we can able to separate, not directly separate. Then whenever if you see FeO, what happened? If you put SiO2, what happened? It becomes slag. Do you remember? Settle down. Okay. Understood? Okay. So one equation is given now. What is the slag? Slag means what? Tell me. Slag means what? It consists of gangue plus flux, correct or not? Gangue plus flux is called slag. Correct or not? Gangue plus, it's called, gangue plus flux is called, what is this? Just remember, very important. Okay, understood? See, we don't want this one, no. How will we remove? By roasting only we can remove. We cannot take this only, this together. When you do roasting, this also roasted, this also roasted. Okay, this one when it forms, immediately we should add SiO2. This will be settled down. Now you come to this one. Okay, then actually we got two kinds of process taking place. Okay, up to this we have one process. After that we should convert it to blast furnace process. Here now we separated, no, this is removed, no, but it's not removed completely. We have only remaining is what? Cu2s plus some small amount of FeSs will be there, some little amount. Okay, that one is called, we can say, matte. I heard about the word matte. It's not completely removed. We have some small amount. So this one matte is converted into Bessemer converter. Again we should do roasting. If you do roasting, what happens? This will be again the same process. Then completely removed. After that we have only Cu2s. Understood? Then that Cu2s is roasted. Are you following? Then Cu2 is roasted, what happened? It becomes what? C2O plus SO2. Again, C2O. Whenever you see C2O, we should add some copper glands. We should add. Then only copper is deposited plus SO2. Correct or not? This copper is called, we can say what? Blister copper. This copper is called what? Blister copper. What is blister copper? On the surface of the copper, we have some small holes will be there. Just like if you prepare dosa, we are getting some small holes on the surface of the dosa, no? Why? Because evolution of those, it's made up of carbohydrate, no? Whenever heat means, what happened? CO2 is evolved. Yeah. We are eating, we are taking plate. Yeah. When we eat, when we prepare dosa here, there's a holes will be formed. The holes due to formation of carbon dioxide. Likewise, on the surface of the copper also, we are getting small holes. That holes due to what? Which gas is evolved means? SO2 gas is evolved. But there CO2, here SO2. There is a, on the surface of the copper, we have small holes will be there. There's a, the whole appearance on the surface of the copper is called, we can say, blister copper. That contains 98% copper. Just remember. Okay. This is all. Okay. This is a way to extract. Understood? Okay. Right. Understood. Sure. It's given in a textbook clearly. If you want me to copy them. Okay. Now, we pass on to the refining process. Simple one. Any examples? This is all you just memorize. Okay. Each and every one memorize. Okay. Native ore, combined ore, leaching process example. Okay. Metallurgy example. Magnetic properties, magnetic separation example, gravity separation example, froth flotation example. Okay. What are the kinds of reducing agent. Okay. What is the purpose for introducing elegant diagram. Okay. These are all just what is matte. Okay. Cu2s and little amount of iron sulfate is called matte. What is blister copper percentage? Okay. Right. One question I expect in this chapter. At least one question. Not more than one. The other chapter is there. Okay. Then refining. So we separated, no? We extracted the metal from the ore. First we washed the ore. After washing process over, we extracted the metal from the ore. Clear? After extract the metal from the ore, we should do what? Refine the metal, isn't it? Refine the metal. So refining. Okay, suppose here, just remember some, I think, five processes are there. Here also based on students, we are giving different kind of coaching, Likewise, based on metal, we are giving different kind of refining process. If you have, distillation means if you have two or three metals in the, at last we are getting two or three, not only one metal, two or three metals are present means how the two or three metals having what? Difference in what? Boiling point. Then only we can use this method, that's all. Okay, understood? Examples go through, your textbook is given. Okay. Then liquefaction. Liquefaction means difference in melting point. Okay, mostly the lead extraction we can do by this method. Lead extraction. After lead is extracted, we separate it, but lead having some other metal is also present. So if you do liquefaction means, if you melt the metal, those metal having low melting point will come down as a, will come down. It melts, it will come down in the slope earthing earth process. It's called, we are using slope earth process, earth furnace, not process, furnace. You take it here. If you apply heat, what happens? Low melting metal having low melting, it will come down as a liquid. That only it's called what? Liquefaction. Okay. The metal having high melting point, it will come there only. It will be there only. It will not come. It will not melt. Okay. Difference in melting point we can easily separate. Okay. Next one. Electrolytic refining. Electrolytic refining. If you want to get 100% refining, we can do this method. Okay. Electrolytic refining. Okay. After get the metal from the ore, it's not pure, no. So impure metal act as what? Anode. Impure metal. Just note down. That's very important. If you connect in different way, the process will do in opposite direction. Then cathode, we connect what? Always pure metal. Understood? Understood? When you pass electric current, what happens? Impure metal means what's the meaning? Pure metal plus impurities. Yeah? Pure metal plus impurities. When you pass electric current, the metal only melt, goes into the solution. But impurities does not have any other melting point. No, it will be there only. It will be settled down near anode. That's why it's called what? Anode mud. Remember, it does not have any other properties. It will be the metal only melt. The metal only dissolve from anode, deposits at cathode. Whenever metals are what character? Metals are positive character. When current is passed, metal dissolves from anode. Whenever it dissolves, it becomes ions, no? Then deposits at cathode. Correct or not? Then all in surface of cathode, we are getting only, already it's a pure. Now the pure metal will be deposited on the surface of the cathode. Okay. Are you following? That's it's called what? Electrolytic refining. Okay. But impurities means it does not have any charge at all. No, plus character, minus character, not have any charge. Then only it will be settled down near anode. That's why it's called what? Anode mud. Okay, right? Are you following? Electrolytic refining. So mostly we can use zinc, any metal, zinc, copper, this and all we can do by this method only. Highly reactive metal, okay, or medium reactive metal also we can do by this method. Most of the metal we can do this method. Okay. Finished? Zone refining, you studied. What is zone refining? We are taking one hollow cylindrical tube. We are taking the impure metal in the middle. we have one electrical heater here. It circulates. It is going to and fro. It can able to move. It is a electrical heater. It is an electrical heater. Okay. Here what? It is nothing but what? Impure metal. This is nothing but what? Electrical heater. Understood? Zone refining means at particular, zone means place, no. At particular place we can separate pure metal as well as impure metal. Zone means the place in which we can separate pure and impure metal. See, whenever if you bring the heater nearer to the impure metal, slowly metals are collected in one side, impurities are collected in other side. But it is not happen within one step. Slowly it will collect. Okay. So if you suppose the heater goes along with this one, okay, the impurities are settled down here only. The metals are melted. It is crystallized and collected in one side. Okay. So from the point and which or place in which we can separate metal or pure metal as well as impurities. That's why it's called zone refining. Mostly 99% if you want to get very pure means mostly we can use what? Semiconductor. Understood? Semiconductor we can able to refine by this method. Semiconductor means it should conduct partially. The substance must be highly pure, then only it can able to conduct electricity properly. So that kind of silicon, germanium, this and all we can do by this method. Understood? Silicon, germanium. Okay. It will not happen within one step. We have to move the heater front and back. Okay. If you do like this, at last the impurities are collected in one side, pure metals are crystallized in other side. We have to do the process repeatedly. We should do. At last only we are getting we can get impurities in one side, pure metals in other side. Okay. Especially semiconductor can be separated by this method. Okay. Sometimes if you want to avoid oxidation, we can pass some inert gases. This and all you just go through. Okay. Right. Next one. Next one is what? Vapor phase refining. Correct or not? Vapor phase refining nothing but fifth one. Vapor phase refining. Vapor phase refining means we are converting metal into vapor by adding, Leon, by adding carbon monoxide. For example, this I am taking Mons process. In Mons process, I am extracting what? Nickel. I am refining nickel. Mons process. Okay. Mons process, after extracting nickel from the usual method, the nickel is separated. No. Now it's a impure. It's a what? It is called impure nickel. Then carbon monoxide is added. What happened? It forms nickel tetracarbonyl. This is vaporized. Okay. Then it is again decomposed to get what? See, impure metal means what's the meaning? The metal plus impurities. The metal only can make a compound with this one, but impurity will not. This will be as it is in left hand side. So metal only can make a compound with the CO to form vaporized. This is vaporized. Then again it will decompose to get what? Nickel plus 4 times CO. This is impure nickel. This is what? Pure nickel. Are you following? Understood? Likewise here, one more method is there. What is one more method? Van Arkel method. Correct or not? Van Arkel method. Here mostly zirconium and what's the other element? Tell me. Zirconium and titanium. Correct? Titanium. This also will come to my mind. Sometimes it will come later, sometimes it will come immediately. Okay. Zirconium and titanium are refined by this method, Van Arkel method. Okay. Here we are using iodine. Okay. Zirconium reacts with iodine, it forms zirconium tetraiodide. Correct or not? Then again it is decomposed to get zirconium plus I2. Understood? You following? Zirconium plus iodine. After that we can balance the equation. Don't worry about that. Okay? Understood? Difference in boiling point, difference in melting point, correct or not? Understood? Here, mostly highly reactive metal, okay? Here, that metal only, not other metal. But here, this is not, other than lead, we have some metal is there. Here we have only impure metal, that metal only. But other than lead, some other metal is present in small amount. So that if you want to separate means we are doing what? Liquation. Okay. So different methods are there. Okay. Right. Usually this is the best method. Usually they are doing whatever the separation, extraction process. Always we are doing related refining at last, mostly. Okay. Okay, these are the information about metallurgy. Okay, so you just go through mostly theoretical topic. All the examples just go through. Then Lillingham diagram just go through. It's also important. Okay. Okay, students. Next class I'll start the 12th standard. Almost I completed. Okay. Then after that